Hi there, welcome to Lecture 4. For people who are in person or on Zoom, we do have an exam coming up next time we meet. If you're in person, you need to buy either a blue exam book, green exam book, or a composition book. What are these things? What do they look like? I'm going to show you. Blue exam book. There they are. One of these. Sometimes they're green, sometimes they're blue. You can get them at the MJC bookstore. Go to the cashier, ask for a blue exam book. They used to have two sizes. I don't know if they still do, a small and a large. Either size works. If you have poor eyesight, you probably want the big one so you can write larger letters. Um, they're also available usually in the vending machine in the student center. Okay, well, what if you can't come to campus? Then what do you do? Well, you can go to any store that sells school supplies and get a composition book. These things, at the stores I shop at, I see them for $1. There's another store I see for $1.25. So they're not expensive. Um, No matter which book you get, all pages must be blank, no pages torn out, no extra pages stapled in, no spiral notebooks. So do not tear any pages out. If you're able to write your name on the front cover, and so the exam is worth 40 points. If you write your name on the front cover, I'll give you 20 out of the 40 points. Um, so it has to be on the front cover, not on the inside page. And these composition books, some of them has a glossy finish on the front cover. Trying to write anything with a pencil on that glossy surface is really difficult. So plan for that. Okay, anything else? I don't know. I don't want to spend too much time on the exam because online students. They don't have to buy the book. Zoom students don't have to buy the book. So I'm going to move on. What's the best way to learn UML-like diagrams? Pretty easy. Get a stack of index cards. Go to lecture 1. Anytime you see anything interesting about UML-like diagrams, grab an index card, write a question on the front of the card, write the answer on the back of a card. Then keep looking through lecture 1. You find another interesting thing about UML-like diagrams, grab another card, write a question on the front, write the answer on the back. Keep doing that till you reach the end of lecture 1. Then repeat for lecture 2, then repeat for lecture 3. Um, and by the time you do all of that, you'll probably be really good at using UML-like diagrams up to lecture 4. So, and we will continue learning more about writing UML-like diagrams for lecture 5, lecture 7, and lecture 8. Okay. Where can you get help? Best place to get help is read the lecture notes, okay? Especially if you're trying to figure out an answer to a homework question, I would start there first. You can also go to the Magic Lab during normal business hours. They are closed 1 hour for lunch. You can come to office hours, which is about a half hour before the class starts. You can post a question in the Canvas QA discussion and homework help board. It's there for students to ask questions and for other students to answer the questions. You can start or join a study group. A lot of gamers in the class, they're on Discord. The issue with Discord is the language is not suitable for small children, and sometimes the topic drifts off um, and is not suitable for small children. So if you have small children in the house, you might want to be extra careful to make sure they can't hear anything being said if you're joining this study group. You can also send me email. What are we doing today? Databases. What the heck is a database? Collection of information stored on a computer can be easily retrieved. I just explained what an Excel spreadsheet is. What's the difference between an Excel spreadsheet and a database? Here's the difference. The data can be queried. You cannot query an Excel spreadsheet, but you can query a database. We're going to do a relational database, which is the data is stored in tables. Why tables? Because in elementary school, junior high, and high school, you've been introduced to tables. You probably use tables. If you haven't used them, you've at least seen tables. And so people are familiar with tables, and which is why I like relational databases. Pretty easy to figure out what's going on. Um, So what does a query look like? Well, suppose you're an airline executive and you want to find out what time a specific flight leaves. You can look that up in the database, send a query. You can find out how many passengers are on it. You can find out who the flight crew is. You can find out how much fuel it's going to take for the plane to get to its destination. You can find out all kinds of things, right? Anything that was recorded, written down, it's available in the database. What about colleges? Well, on day one of a new class, a college professor, first thing they want to know is who is in my class, so they can ask the database to print out names of all the students in the class. Um, and there's a lot of people who use college databases to do research. For example, do night students do better than day students? Do students who live in town do better than students who live outside of town? Do older students do better than younger students? So they ask all these questions, and they can look up data in the school database and get some answers. Um, who uses databases? Just about every company uses databases. Example is your grocery store. When you take your item to the cashier and they scan it over a barcode, you hear the beep. What's going on? The beep means that it read the barcode. That barcode is a ID of that product. So it sends a query to the database saying, "What is this thing?" And the database say, "Oh, that's a can of peas for 99 cents." And so what you'll see up on the monitor is peas 99 cents. So all of that magic happens because it's doing a query. It uses the ID and says, what product has this ID? And then it gets all the information about it. Um, Another example would be if you go to a doctor or dentist, you ask for an appointment, the receptionist is typing away on their computer. What are they doing? They're querying the database. They're trying to find you an open appointment. And the list goes on and on and on and on and on. Just about every business uses a database. The one exception might be the lone employee or the lone owner. And the only employee he has is himself or herself. They might not need a database since they're the only ones working their business. And just about everybody else, just to compute payroll, most businesses now will buy software that does that, and that software is connected to a database. So payroll is very difficult, especially for hourly people, because the number of hours changes every day. And then if they do overtime, the rate of pay changes. Um, and the list just goes on and on and on. You got to take out taxes, you got to take out Social Security taxes, you got to take out their contribution to healthcare plan, you got to take out their 401k contribution, and the list just keeps going on and on. It's very complicated, and so just about all businesses will buy some software to do that. Trying to adjust my table here. Okay, moving on. We're going to use SQL, structured query language. This is the language for talking to SQL databases. There are other kinds of databases out there, but SQL is very popular. A lot of databases are SQL databases, and that means that you have to know SQL to talk to this database. So before we can talk to a database, we have to have a database management system, a DBMS. What is a DBMS? So that's the thing that actually creates databases. Database is the data. Something has to create that data, and that's what a DBMS does. DBMS does all kinds of interesting things like install a database, install updates to the database. What do you mean by updates? Well, employees, they're changing all the time, right? Every year they get, probably a higher salary. Some of them move to different offices. Some of them have a last name change. Some of them get promoted. I mean, employees, things are always changing. So you constantly have to update that database. You want to control access. Only HR people should be able to see HR information because, there's a lot of sensitive information there, social security numbers, pay, amount of pay, and yada 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 yada, very sensitive information that only HR people are supposed to be have access to. Nobody else. You don't want the janitor having access to that. That's for sure. And the same thing with inventory control, right? The only people who need to look at inventory databases are the people who are doing inventory control. Um, So with a DBMS, you can add new records, right? New employee comes on, joins the company. You got to add that person in. You can edit. So, I already talked about that. Delete old records. When an employee leaves, you can delete their record. You can create forms. I'm talking about, so like when you get first time to a new doctor or dentist, what happens? They give you an iPad, and on that iPad is a form, your name, your address, what's your medical insurance number, what kind of illnesses have you had since birth, any diseases, any surgery. Yeah, the list goes on and on and on. Well, all those answers are stored in a database. Okay. Um, and so that thing that you're filling out is a form. And that's usually how we get information from people. We give them a form and they fill it out, and then the answers go into the database. We already talked about querying a database. So a report is the results of the query. So if you ask, how many people are on a flight, it'll say, there are 60 people on this flight, and they can put it in a nice formatted report. Okay. What are some popular DBMSs? Microsoft Access is very popular because it comes with Microsoft Office, at least the professional version. If you're on a Windows machine, doesn't Microsoft Access does not work on Macs, only works on Windows machines. MySQL back in the day was hugely popular because it was free. Well, it's no longer free, so it's not as popular. But a lot of people still use it because they grew up with it. They got used to it. They used it for decades. So yeah, they just kept using it. So they just have to pay for it. SQL Server is popular. It's a Microsoft DBMS. So what DBMS are we going to use for this course? We're going to use HSQLDB, and the reason why you don't have to configure it to get it up and running. All these other databases, you have to spend hours reading the documentation to configure it. By configure it, I mean, how do you create a new database? How do you create your new users? How do you assign new users to specific databases? And how do you give users like permissions? Like some users need to only be able to read the database. Other users need to be able to write and overwrite and delete information in the database. And the list just goes on and on and on of all these things that you have to configure before you can even start using it. Well, you don't have to do any of that with HSQLDB. It's up and running. So how do I get it? Pretty easy. Go to Canvas, go to modules, go to resources, gotta find it. Resource. I missed it. There it is. And click on how to install HSQLDB. And this is what I'm gonna do. I'm just gonna copy out everything inside this box. Try anyway. Right click, copy, and I'm going to go to CMD prompts. How did I get to the CMD prompt? I just looked it up. Just type CMD and you'll find it here. CMD. There it is right there. Well, I already did that, and it's right here, and it's in the spot where I want it. So let's just go with this. I'm gonna go to junk, and then all I'm gonna do is paste. And what it's doing now is installing Java because HSQLDB is a Java app, so it needs Java installed in order to run. So it is installing Java. Give it a minute. Let's see if it's going to, yep, there it is. It's installing Java. Then it's going to install HSQLDB. And then once that's done, it's going to launch HSQLDB. Let it finish. Okay, here we go. There it is. It launched. Now, do not change anything here. This is part of the configuration. If you change any of this, it's going to work. So just hit OK. Don't click on anything. Don't change anything. Don't delete anything. Just click OK. And here we are right here. In this box, we write our SQL commands. I'm going to make this box bigger because we got a lot of SQL commands we need to write in there. So there it is, up and running. We're ready to go. Now, this only works on Windows. For what if you own a Mac? Well, if you're really, really good and you know what you're doing, you can get HSQLDB working on a Mac. And so a long time ago, in a previous class, I had a student who actually worked for Apple Cupertino. and he helped everybody in the class who had a Mac laptop get this thing working on their Mac laptop. Um, so I know it's possible, but I know it's extremely difficult because just about everybody was having problems. So your best bet then is to just go online, go to Google, type free SQL editor, and try to find an free SQL editor that you can work with. Um, you might have to click on several of them before you find one that looks easy enough to use. So I don't use online SQL editors. I use the command line, um, or I use tools that come with the DBMS. So I don't use online stuff, so I can't help you with that. You can go to the Magic Lab and see if they can help you get HSQLDB installed on your Mac if you have a Mac. I don't know if they can. They're certainly will have a better shot at it than me. So I don't have a Mac. So they do. They have lots of Macs, or at least they did in the past. I don't know about nowadays. All right. So the rest of these instructions is the traditional way to install it, skipping all that. Just do it my way, a lot quicker, a lot faster. Better than reading through all these slides and doing all this stuff. Okay, there we are. So finally caught up. So a database is a collection of tables. We are just going to create a one table database. Keep it simple. We're just trying to learn the basics. That's all we're trying to do. Here is the table that we're going to use. I list the name of the table up in the upper left-hand corner. So the name of this table is song. This row in yellow, that is not data. That is not data. Those are the field names for each column. So this is a field is a column. Song name is the name of this first field or column. Artist code is the name of this field or column. Album number, that's short for number, is the name of this field. Track num is the name of this field, and media type is the name of this field. So what does all this stuff mean? Yellow Submarine is the name of a song. BET is shorthand for Beatles. CARP is shorthand for Carpenters. RS is shorthand for Rolling Stones. The album number, this person has a collection of albums. So their first album was 1, their second album is 2, their third album is 3, and on and on and on it goes. So their 146th album contained the song Yellow Submarine. The track number is what song is it? So the first song on the album is 1, the second song is 2, the third song is 3. So this is the third song on this album. Now, I made these track numbers up. I made these media type up. I have no idea if there's any such thing as a CD where the third song is Yellow Submarine. Highly doubtful since I made all this stuff up. What the heck is a CD? Well, the slide was made a bazillion years ago when you went to the music store and you bought music, it came in a CD. So what the heck is a CD? These are CDs, and that's what music came. You went to the store and you bought one of these, and it had your music on it, and you pushed it into the computer, and it played. Okay. MP3 is a file format for storing sound files. So music is sound, so you can store songs in MP3 files. Don't know if anybody does that, but it's possible. The name of this table, hopefully you can figure this out. Hit the pause button if you need time to think. I'm going to tell you the answer now. The name of this table is songs. What are the names of the fields in this table? Hit the pause button if you need some time. You should write this answer down on a sheet of paper, by the way, so that it's for real. Yeah, I know what it's like if you don't write things. You're just going to half guess and whatever. I know what it is. But if you actually force yourself to write it down, then you actually have to know what it is. I'm going to tell you the answer now. The names of the fields are song name, artist code, album number, track number, media type. Those are the names of the fields. Okay. What information is stored in the first record? So what's a record? A record is a whole row. This is the first field. So this first record contains the song name Yellow Submarine, sung by the Beatles, the 146th album in this person's album collection, the third song on the track, and it's on CD. Okay, the first record is here. This thing up here is not the first record. Those are the field names. The first record of data is on the second row. Just remember that. Okay. People get so confused. You won't believe how many people write this for the first record. That's not the first record. Those are the names of the fields. All right. So this whole yellow line is everything we know about the song Yellow Submarine, sung by the Beatles, 146th album, third third song on the album, and the album is a CD. Okay, that's all the information we know about that song. What information is stored on the second record? You should pause this video and actually write this answer down. The answer is the song name Help, sung by the Beatles, the 146th album in the collection, the ninth song on the album, and it's on CD. Okay. And there's one more for the third record. You should pause the video and write this down. The third record is Close to You. That's the name of the song sung by the Carpenters. The 78th record in the collection, the 16th song on the album, and it's on CD. All right, so enough of that. Let's move on to something else. Let's figure out how to read a table. And the reason why this slide is even up, have in the past people who never had to read a table. And when I was doing all of this, they stopped me and says, I have no idea what you're doing. I never had to read a table before. Can you slow down? All right, so I'm going to explain to you how to read a table. Who is the artist for the song Angie? In order to figure this out, first thing we got to do is find Angie. Well, it's the name of a song, so let's go to the song name column. This is the song name field. So that's not Angie, skip that. That's not Angie, skip that. That's not Angie, skip that. There it is. Everything that we know about Angie is on this row that's highlighted. We want to know who the artist is. Well, that's the artist code. The intersection of this row with this column is Rolling Stones. The Rolling Stones sung Angie. Okay? We're going to do one more example just so we got this. What's the media type for the song Satisfaction? Satisfaction is the name of a song. So let's go to the song name column. That's not satisfaction. That's not satisfaction. That's not satisfaction. That's not there it is right there. We found it. Everything in this row belongs to the song Satisfaction. What are we looking for? The media type. Well, the media type, the intersection of this row with this column is MP3. Okay, that's how you read a table. Hopefully we got that. Let's talk about data types. Int is shorthand for integer. These two are identical. This is the shorthand version of integer. What is an integer? It's a number without a decimal point. Examples are minus 1, 2, 3, 0, 1, 2, 3. Notice there's no decimal point. These are numbers. Double and floats. So on this DBMS, there is no difference between a double and a float. In other DBMSs, there is a difference, but not for HSQLDB. So what is a double or a float? It's a number with a decimal point, minus 1.230, 0.23. Why is it called a float? Because the decimal point in a floating point number can float. What do you mean can float? I mean, 1.23, 1, 2.3, 1, 2, 3.4. So this decimal point can float around in that number, right? Could be anywhere. So that's okay. So now we move on to characters. So some people pronounce this char, some people pronounce it car. It's shorthand for character. And this N here is a number. So if I go car 3, it means the most number of letters I can store in this field is 3 letters. I can store the letter A, but it's going to make room for 3 letters. So what happens to the other 2 places? We fill them in with the space key, the space character. So this is going to be what's going to be stored here is A space, space. What happens if I have only 2 letters? Well, then there's going to be an empty space, and it's going to be filled in with a space character. So it's going to be A, B space. And 3 is we're going to make room for 3 characters. What if we give it 3 characters? Well, it's just going to store the 3 characters. There's no need for spacing. We asked for space for 3. We gave it 3 characters. Everybody's happy. Varchar stands for variable car or variable char. And there, if I do a varchar 3 and only give it 1 character, then that's all it's going to store. It's just going to store the 1 character. There is no extra blank spaces stored after that A. If I give it 2 characters, it's going to store exactly those 2 characters and no other spaces. And if I give it ABC, because we asked for varchar 3, it made space for 3 characters. We gave it 3 characters. Everybody's happy. Date is exactly what you think it is: year, month, day. I like this format. You can use any format you want. Most people will probably write the day that looks something like this. Get off the cap. Come on, stop. Somehow why is the cap locked? Let's try that again. Okay, finally. 01/2025. Oh, needs a comma. So you can write it like that, and there's half a dozen different ways to write a date. I like, let's do 2021 January, first day of January 2022, February, second day of February 20, whoops, I want 22, 2023, March 03, third day of March. What I like about this is date order is the same as alphabetical order. So if you import this into an Excel spreadsheet and it happens to come in as a string, you can sort it. By word, right? And put it in alphabetical order. The alphabetical order would be exactly the same as the date order. So very, very easy to sort these things by date order, which is why I like this. And to me, this is much more easier to read, right? First you say the year, then the month, then the day. And doing this sounds really confusing. First you say the month, then you say the day of the month, and then for whatever reason you hop back over to the year. It just seems like it's out of order. It doesn't make a lot of sense. You definitely cannot sort this alphabetically. It's not going to come out in date order. Anyway, it's your choice how you want to store dates in HSQLDB. Well, the dates, you can't just willy-nilly make up stuff, right? It has to be supported, how you write those dates. Okay. A time is hour, minutes, seconds. The seconds is optional. So I could say 01, 02. I don't have to put the seconds. In fact, I don't even have to put the minutes if I don't want to. Most people write hours and minutes. And a timestamp is the first half of this is the day, and the second half is the time. So it's date and time combined together, concatenated with a space between them, right? There are lots of other different data types. We're just going over the very basics. For this lecture, we're going to primarily focus on integers, doubles or floats, char or varchar, and that's it, just the three. Hopefully we can do three without any issues. We'll briefly mention date, time, and timestamp, but we're not going to write any code for it. All right, moving on. So a char or a varchar is a string of characters. What is a character? It's those things you see on the keyboard that you can type, and what pops up on the screen is, a letter or a character or a symbol, right? If you press the letter S, then you'll see S on the screen. That's what I'm talking about. That's a character. This is not char or a varchar because this is an integer. There's no single quotes from front of it or behind it. This is a string. For one thing, it has words in it, so it definitely can't be the number. And it's enclosed in single quotes, so that is a string. This is not the number 1, 2, 3. It's enclosed in single quotes. This is the string 1, 2, 3. So what's the difference between an integer 1, 2, 3 and the string 1, 2, 3? Well, you can do addition, subtraction, multiplication, and division on numbers. 1, 2, 3 plus 1 is 124. You cannot do math on strings. You can't say I live on plus the string 123. What that you can't do addition, right? That doesn't even make any sense. So you cannot do addition on strings. What you can do is concatenation. You can concatenate this string with this string and with this string to create one huge string. And this is a concatenation of I live on 1, 2, 3 Main Street. The concatenation of the three strings combined into one string. That's what concatenation means, combined. Okay, hopefully that makes sense. This n is the most number of letters you can put into that field. And so if I say car 3, the most number of letters I can put in that field is 3. So if I try to store A in a car 3, it will store the A, but it made room for 3 characters, and it's just going to put empty spaces in the two slots after the A. If I put in two letters, it's going to put in empty space after the second letter. And if I do three letters, well, I asked for three letters. It made room for three letters, and I gave it three letters, so everybody's happy. No need, no extra spaces, no problems. Varchar, we don't add the extra spaces. So if I only put one character in, then it's only going to store one character. If I store two characters, it's going to store two characters. If I put in three characters, it's going to store the three characters. No extra spaces. That's the difference between these two. Int and integer are numbers without decimal places. Look at all these numbers. None of them have a decimal place. This is not an integer because it has a decimal point. This is definitely not an integer because it has words. This is not an integer because it's surrounded in single quotes. This is a string. Okay. Doubles or floats have decimal places. Decimal places. Minus 1.23, minus 1.2, 0.0, 1.2, 1.23. There's a decimal point somewhere in there. This is not a double because it has words and it's a string. Look at the single quotes. This is not a decimal because it's surrounded by single quotes. This is a string or a car or a varchar. What about this guy? Is this a double or a float? You might want to hit the pause button and think about that for a minute. I'm going to prove to you that it could be a double. Hopefully everybody agrees that says $10. Hopefully everybody agrees that also says $10. But where's the decimal point in the 0 cents? Well, it's implied. We know what it means. It means $10 with no cents. We don't have to write the .00. We know that. We know it's there. We just don't write it. So this was 1, 2, 3 could be an integer or it could be a double. Okay, that's what I'm trying to tell you. Depends on context, right? It's implied. If it's interpreted to be a double or a float, it's implied there's a decimal point there with a 0 on the end of it. Dates, I like year, month, day, because again, I told you, because date order is the same as alphabetical order. Makes it real easy to put things in date order, just sort it alphabetically. All right, timestamp. Oh, I missed time. Time is hours, minutes, seconds, and a timestamp is both the date and the time. Okay, we already talked about that. Moving on, moving on, moving on. Okay, we're going to write the SQL command to create this empty table. Now, be careful, careful, careful. You won't believe how many people say, well, here's the command that creates this table. This doesn't create anything. All right, this does not create that table. So what is that thing? Now, that thing is a template that we're going to use to create the table. Skip that. Let's go over to here. All right, so how does this template work? Well, we're just going to look at the template. The first word is create. It's all in capital letters, so let's just copy it out. Create. The next word, oh, forgot the E. The next word is table, all in caps. Copy that out. Do not type name of table. Instead, type the actual name of the table. Well, the actual name of the table is song, so let's type songs. Okay. And then it says a parentheses, close parentheses, all SQL statements in and a semicolon. And what goes in here? Do not type name of field. Type the actual name of the field. Well, the name of the first field is song name, so type that. Do not type data type of field. That's wrong. Type the actual data type. Well, song name, remember, had things like close to you and satisfaction. So those are all words. So it's going to be a var or a varchar. Let's do a char. And well, how many characters is in a song name? I don't know, 25, 30? Take a guess. Don't do this because it's going to reserve space in the database for that many digits. And if you, there is no way a song title can have that many digits, so don't be stupid about this. You're just wasting resources. Okay, and so I'm going to say 30 characters. What if a song has 40 characters in it? Well, it's only going to save the first 30 and throw away the last 10 because there's only room for 30 characters. So that's what happens. Notice the comma here, so let's put a comma here. And then the next thing it says name of field. Well, let's go to the next field, which is artist code. And so artist code was things like Bet for Beatles and CAP for Carpenters and RS for Rolling Stones. So it's a character. We could say 10. I'm gonna fudge this and 30 because I want everything to just be 30, 30, 30, 30, all the way down 30. All right, and then the next field is album number. Well, album number is not a string; it's a number. Remember, it had numbers like 1, 2, 3, 4, 5. That's an integer. So then the next field is the track number, and that is not a string because it's an integer, right? 1, 2, 3, 4, 5. So that's an int. And then the last thing is media type. And media type was, a CD or um, some file format that I've forgotten. But it's letters. So car. Uh, so we know that it doesn't have that many letters. We could have said 5. But I just want 30, 30, 30 all the way down just to make this super, super easy to use. Okay. Now, back in the old days, if you added that extra comma on the bottom, it will complain loudly. Hopefully they fixed that, but I've never tried it. So I've gotten to the habit of not including that extra comma as on the last one. And this is the SQL command to create this table. Hopefully you understand. What you should do now is write the code to create this table. Hit the pause button. You're going to need it. Um, okay, I'm going to show you the answer. Hopefully you wrote something like this. Okay. All right. So let's actually, this is going through it step by step, everything I did. So if I went too fast, you can go back over here and look at it step by step. All right, what I'm going to do is copy this out because I know this has no errors in it, no typos, no misspellings, no nothing. I'm going to come over here and we're going to create this table. You watch this. This table is going to appear if this is successful. Let's see. I'm going to hit the execute SQL, and there's our table right there. We've just created an empty table. There's nothing in the table. We haven't put anything in the table yet. That's the next step. Let's put something into this table. Okay, we want to put the first record, Yellow Submarine, Beatles, 146.3 in CD. Well, how the heck are we going to do that? This command will not install all of this information into this table, okay? That's a template. We're going to follow the template to install all of this stuff. Well, how do we do it? Well, we're going to play the same game. First thing we're going to do is just write insert because it's all in caps. Uh, why does the cap lock keep coming on? I don't know. Insert into, because into is all caps. Do not write name of table. Instead, give me the actual name of the table. Well, the name of the table is songs. We're going to cap values is capitalized. Just write it out. Open parentheses, close parentheses, all statements in Java end in a semicolon. What goes inside here says do not write value 1. What we want is the value in the leftmost field, which is yellow submarine. And that is a string, so it has to be enclosed in single quotes. Submarine, comma. Beatles is next, B-E-T, comma. The album number 146. Now, 146 is an integer. It has numbers like 1, 2, 3. So do not put it in single quotes. Just write it as is, 146. The next one is 3. That is not a string. That is an actual number. So the 3 goes here. And then CD is a string because it has letters in it. So enclose that in single quotes. And there you go. We just entered our first record into, well, this is the command to enter our first record into a database. So it's probably, what I wrote is probably full of typos and errors. I've done this way too many times. I've learned don't put in what you typed into the database because you're just going to muck it up. So what I'm going to do is just keep going. We're going to see how to get the second field. Let's see. Yeah, well, why don't you write the code and get the second field in? I'll pause the video, write that code. So I'm going to give you the answer now. Uh, insert is all caps, so just type it out. Into is all caps, type it out. Do not type name of table. Instead, give me the name of the table, which is songs, capital S. Values is all caps, just copy it out. Open paren, close paren, all statements in Java end with a semicolon. What goes here says value 1. Oh, where's the second row? We need the second row. Darn it. Okay, there's the second row. Okay, write the code to put that in there. I messed up, sorry. So help is the name of the song. It is a string, so it has to be in single quotes. The next one is bet. That is the name of a band. So it's a word, so it has to be in single quotes. 146 is just a plain ordinary number. 9 is just a plain ordinary number. CD is, their letters, so it's a word, so it has to be enclosed in single quotes, and that's how you get the second record in. All right. Um, and we can check our answer. Insert in the string values help Beatles 146. Yep, that answer is correct. Okay. And you can, if you want to, you can pause the video, type the third one in without looking at the answer. I'm just going to go ahead and finish this off. So I'm pretty sure that these are okay. See if there a better one I can pick. I am definitely sure this one's okay because I checked this over and over and over again when I did this. So I know that's perfect. No errors, no typos, no nothing. So let's just use that one. I'm going to paste it in here. There it is. And then I'm going to hit execute SQL. And it says update count 1, which what does that mean? It means we changed a record. So when we inserted this, we added one new record. When we inserted this, we added one new record. When we inserted this, we added one new record. When we inserted this, we added one new record. When we inserted this, we added one new record. That's why the update count is 1, is how many records did you add for each command. Oh, well, it only shows the last command. Okay. So we've populated our table. It is now to write a query. Now, the query is the hardest part, learning how to write the query. So I'm going to make this easy by splitting this query up into 4 parts. And we're going to look at each of the 4 parts. Now, remember, we are only writing 1/4 of the query. We're not writing the whole query. We're just writing 1/4 of the query, just so we can break this up into parts so we get a better handle on what the heck's going on. We're going to use the select clause. And what the select clause does is selects which columns are going to be shown in the output results. Okay. And the template is right here. Select name of field, comma, name of field, comma, name of field, and just keep going until you stop until you want to stop. So let's take a look at this. How do we get all 5 fields in there? What is this in the way for? Okay. So we start off, the first letter is select, and then do not type name of field. Actually, give me the name of the first field that we want in the output. Well, that would be song name. And then if we want all the fields, then the next one is going to be artist code. And the next one's going to be album number. And the next one's going to be track number. Can I make this any wider? Don't know yet. Yep. Okay. And the last one is media type. All statements in Java. Oh, we're not ending it. This is only 1/4 of the query, so don't end it yet. So there's my answer. We can check it to see if it's right. There it is. Do we match up well with that? So select song name, artist code, album number, track number, media type. Yep, it matches perfectly. Oops, there's no parentheses there. Silly me. Okay, do we understand? This is going to select all the fields, okay? All the fields. We're going to see information about the song name, the artist code, the album number, track number, and media type, because that's what we selected. All right. You write the code to select only display the names of the song. That's it. That's all we want to see. How would I change this so I would display only the names of the song? Okay, let's write that code. So you should hit the pause button and actually figure this out. First word is select. Next word is name of the field. Well, the only field we want is the names of the songs, and that's going to be in this field, song name. And we're done. Okay, and that is 1/4 of the query. Let's check our answer. Yep, select song name. What did we write? We wrote select song name, so it's a perfect match. Okay, hopefully this is making sense. This is only 1/4 of the query, by the way. We still got 3/4 left to go. You write the code to display only the names of the songs and their artists. Hit the pause button. You're going to need it. Okay. So we always start off with select names of the songs. Well, that's going to be song name, comma, and then what else is it asking for? Artist. So artist code. And that's it. That's all we got to do. Okay. Now we're only going in the output, we're only going to see information about the song name and the artist code. It won't tell us about album number, won't tell us about track number, won't tell us about media type. All right. Hopefully that all makes sense. So all we're going to see is these two fields. We should check our answer. Always, always, always check your answer. Select song name, comma, artist code. It looks right to me. Okay. You do this one. Select cause to display the album numbers and the track numbers of the song. How do we do that? I'm going to show you the answer now. We always start with the word select, and we want to find the column that has album numbers in it. Lo and behold, it's right there. So album num and track num. There it is right there. So track num. That's it. Let's check the answer, make sure we got it right. Select album number, track number. That looks right to me. Okay. Are there any more of these? Oh, shorthand, select star. That selects all the columns. Okay. Yeah, a lot of people use this shorthand. I use it quite a bit because it's a very frequent query. Give me everything. Give me all the fields. All right. Let's move on to the where clause. So the select clause will select which column we want. The where clause selects which rows we want. And the format is where, name a field, and equal to some value. So what are we trying to do? Let's get a mission going here, or a task, or whatever you want to call it. Write the where clause to find the song that is named help. Okay. So we're doing this because we're only interested seeing in the output information about help and no other song. Well, how do we do that? Well, first we write where, because it's all in caps, so capitalize it. Where, name of field. Well, the name of field that we want is where a song has the word help in it. Well, that would be song name. So that's our field. So song name equals, and the only thing we care about is help, the song name help. That's a string, so it's got to be in single quotes, help. All right. By doing that, we've just selected this row. That's the only row that's going to show up in our query results is this row. Let's check our answers. Let's make sure it looks okay. Where song name, oops. No, that is a single equal sign. Thought I messed up. Help, okay? It matches. All right, let's do another one. You write the code to find all songs that are sung by Rolling Stones, okay? Pause the video. I'm going to give you the answer. We start off with where, and Rolling Stones is in the artist code. So where artist code equals Rolling Stones. All right, let's see what the answer is. Okay. Got single quotes. I don't think it makes a difference. Does it make a difference? Been using single quotes. I don't know why I switched over to double quotes. Getting confused. I don't think it makes a difference. Doesn't matter. We can check it later. So with that matches, except for the single quote versus double quotes. All right. And so what songs is this thing going to find? So it's only going to find Angie and Satisfaction because those are the only two songs that are sung by the Rolling Stones. So everything in yellow. That's the rows it's selected. Okay. You write the code, find the where clause to find all songs that are on album number 78. Okay. So we start off with where because it's all capitalized. And then we got to find album number. Well, there it is right there where album num equals, and what's the number we want? 77, 78. All right. And that is going to select this middle field. All right. Let's take a look and see if we got it right. Hopefully we do. Where album num 78, it is right. Okay. Uh, find the clause to find all songs that are on track number 1. Okay. That's pretty easy to do. We always write where all in caps. Well, you don't have to be in caps, but tradition, I don't know. A lot of people do write it in caps. It's not necessary. Well, the column name for track number is track num. And we are looking for all songs that are on track number 1. We're looking for that. So which rows is it going to be? Well, that's not one, that's not one, that's not one, that's not one, that's not one. This is going to just return emptiness, nothingness. Okay. This happens a lot in database queries. If you already knew what the answer was, why would you be asking a database for the answer? You don't know the answer, so you're just trying out stuff. Let's see if we got the right answer. Where, it's not single quotes because it's a number. Sorry. Messing up, which is why we do a check all the time. Okay. Hey, I'm not perfect. Never said I was. Find the clause to find all songs that are on CD. Okay. We want to find all songs that are on CD. Those are the only rows we're interested in. So that is going to be a where. The CD thing is in media type. So where media type equals single quote because CD is definitely a string. So it's going to look something like that. And it's going to pick these top 3 rows. All right, let's take a look, make sure that's what happens. Let's just move on to the next slide. Okay, let's compare slides. Where media type equals CD in single quotes, that is correct. Okay. All right, let's do some math. I'm going to launch paint.net to explain these concepts. And we're going to draw a number line. Hopefully it'll refresh your memory from grade school, junior high. We'll push this up to a 7. Should give us a nice number line. Okay, now I want to find 0. So it's going to be text. That looks like about 0. Let's up this font size so it's very easy to read. And somewhere around in here, we'll put a 1. And somewhere around in here, we'll put a 2. And somewhere around in here, we'll put a -1. And somewhere around in here, we'll put a -2. Okay. So as we go left, we go from 2 to 1 to 0 to -1 to -2. The numbers keep getting smaller and smaller and smaller. So this means less than. Okay. Let's look at this. Let's just do numbers. This is getting way too complicated. 1 is less than 2. Everybody agree with that? Yes, this is true. 1 is less than 2. 1 is less than, that should be a 2. 1 is less than 2. Okay, let's do a false case. It is not true that 2 is less than 1. This is false. Okay. Let's do greater than. Greater than means on that number line, as we go to the right, the numbers keep getting bigger and bigger and bigger. -2 to -1, -1 to 0, 0 to 1, 1 to 2. Numbers keep getting bigger as we go to the right. Right? Okay, let's come up with some example where we have greater than. How about 2 is greater than 1. That is a true statement. 2 is greater than 1. Let's do the reverse. 1 is not greater than 2. That's wrong. 1 is not greater than 2. All right. Let's do greater than. We did greater than, right? I think we did. Yes, we did. Let's do less than or equal to. So this means less than or equal to. Either can be true. Either can be true. So what are you talking about? 1 is less than or equal to 2. Why? Because 1 is less than 2. And because 1 is less than 2, this whole statement becomes true. Okay? Hopefully that makes sense. Let's change this. Let's just go down here. 1 is less than or equal to 1. That's a true statement. 1 is equal to 1. True statement. All right. Let's come up with a false statement. 2 is less than or equal to 1. Well, that is false. False. 2 is not less than 1, and 2 is not equal to 1. Okay. Hopefully this all makes sense. The last one is not equal to. 1 is not equal to 2. This is not equal. It's not true that 1 is not equal to 1. That's false. All right. Hopefully that gives you a basic understanding of what's going on. What is that doing? Okay, let's do and. So this is supposed to be examples. I didn't see any examples. Oh, this is just showing you that we can use less than to pull queries. Okay, I see what's going on. All right, let's write this query. All right, we're going to start with where. Album number. Well, we know what the name of the field is for album number. We've been using it all night. It's album_number. And what are we trying to do? Less than 100. Okay, so which of these which of these rows is it going to pick? It's not going to pick 146. That's greater than 100. It's not going to pick 146 greater than 100. 78 is less than 100, so it is going to pick close to you. 24 is less than 100. It's going to pick Angie. 24 is less than satisfaction. It will pick satisfaction. So we're picking up these last 3 rows. That's what's going on. And I bet I have a slide too. Yep, there it is. Last 3 rows. Okay, that's for less than. Let's look at and or. And stop that. And both sides have to be true. Or only, no. Let me see. One side has to be true. At least one side. Sometimes both sides are true, but there's got to be at least one that's true. If there's at least one that's true, then the whole thing is true. For and, both have to be true. Okay. Are there any examples in real life? I don't know. It's hard. I'm not going to worry about real life. I'm just going to confuse myself. Let's just move on. We don't have a lot of time. Find all songs that are sung by Beatles or by RS. Okay, how do we write that code? Well, we obviously going to start with where. And we want to look at sung by the Beatles. So that's artist code equals bet. Or sung by Rolling Stones. And that's going to be artist code. Rolling Stones, RS. There it is. Okay. So which one of these is it gonna pick? It will pick Beatles because that's one of the choices. So Yellow Submarine is in, Help is in. It will not pick Carpenters because Carpenters is not the Beatles and it's not Rolling Stones. So um, can't pick that one. It will pick Rolling Stones because it says, it's either going to be Beatles or Rolling Stones. I don't care which. There should be a single quote there. As long as one of them is true. And so Angie's going to be included, and so is Satisfaction. So Yellow Submarine, Help, Angie, and Satisfaction. The only one not included is Close to You. Let's check our answer. And there it is. And where artist code equals Beatles or artist code equals Rolling Stones. So there it is. And it's going to pick all these rows in yellow. It's going to pick these two because that's the Beatles song. So it's these Beatles or Rolling Stones. So the Beatles sung these two. It's going to pick the bottom two because the Rolling Stones sang that song. It's an or. Um, yeah. So either one can be true for the whole statement to be true. So this is true that um, um, we have some songs sung by the Beatles, and we have songs sung by Rolling Stones. When that happens, we pick both songs sung by Beatles, songs sung by Rolling Stones. Hopefully, this is making sense. I know this is confusing. Practice makes perfect. That is the only way you're going to figure this out. Write the where clause to find all songs sung by the Beatles and are on CD. Okay. Let's work on that. You should hit the pause button and try this yourself. We know the first word is always where. And so we'll go with sung by the Beatles as a artist code right here, where artist code. And we're looking for the Beatles and are on CD. So there's our and media type is on CD. All right, there it is. So what is it going to find? Um, the Beatles are right here. So Yellow Submarine is from the Beatles and is on a CD. That's included. Help is the next song, but it's also on a CD, so that's going to be included. And that's it. Carp is not a Beatles. Rolling Stone's not a Beatles. And so it won't invite those. The only ones we're going to see is the first two, Yellow Submarine and Help. Let's see if that is the correct answer. This outlining the first two rows. Let's see if we match that. Artist code, Beatles, and media type CD. It matches. Okay, so we got that one right. Yay. Okay, so again, we started out by saying we were going to divide up the SQL query into 4 parts. We are now on part 3, which is the from clause, which is the easiest one of them all, because you capitalize from, and you write the name of the table songs. That's it. That's all you got to do. Okay, that one's done. All right, moving on to the last one. Order by. How do we want to put things in alphabetical order? What do you mean in alphabetical order? Well, let's look at song names and put that in alphabetical order. The first one is Angie because it's an A. Close to You is next. Close to You is next. H, I think, is next. Help. S is Satisfaction. And Yellow Submarine. Okay. That's what I mean by putting things in alphabetical order. We can also put things in numerical order. Let's put it in order of album number. Well, the lowest album number is 24, but I got 2 of them. So 2 24s. And then the next one is 78. And the one after that are 2 146s. So that's how you would put album number in numerical order, just like that. Okay, we got this. It makes sense, I hope. All right. Um, some examples. Order by clause that alphabetizes the output of song names. Well, how do we do that? You should pause the video and figure that out. So it's going to be order. That's the first word, and it's all in caps. By, that's the second word, it's all in caps. And what are we looking for? We're looking for um, alphabetize the output of song names. Well, that's easy. Just go song name. All right. Oops, misspelled order. Let's check it. Oh, we don't know. We can't check it. Let's do the next one. Order by output of artist. So artist code. So the next one would be order by artist code. Okay. And the next one is order by output of the album number. Okay. So we want to put the album number in numerical order. Pretty easy. So we go order by album num. Okay. Help if you could spell. That is correct spelling. Okay. Um, and then the last one is alphabetized by output of media type. Okay, so we're going to go to order by media type. All right, let's check our answers. Order by song name, order by artist code, order by album number, order by media type. It checks out, it works. Okay. All right, we're now ready to combine all four into one single query. Okay. Now, these square brackets on the last two means these are optional. You don't have to include them in if you don't want them. All right. Select all fields from all rows. You should hit the pause button and actually try to figure that out. I'm going to give you the answer now. We want all fields from all rows. So we're going to start with select. We're going to select them all. So you could write a star to select them, or you can just type them out. Your choice. Album number, track number, and finally media type. Come on, stop that. Media type. All right, that's the select clause. Yes, we could have just said select star, but maybe I like pain and agony. From the name of this table, which is songs, where what are we doing? Select all fields from all rows. So it's all fields in all rows. We don't need a where clause. A where clause will take out some of the rows, and we don't want it. We want all rows. And there's no order by, so we're done in this in a semicolon. Will it actually work? Well, it should. It's fine. There's the answer. What did I write? I wrote song name, artist code, album number, track num, media type matches. All right. Okay, so that's it. Now we got to do the from part. All right, from songs. And that's all we got to do. Let's see if this actually works. We're still not there yet. Where's the end of this? Okay, I'm going to assume this is correct. And let's put it in. Try it out. See what happens. What could possibly go wrong? That's not it. Let's try that again. Copy. I I lost it. Is it this one? No, it's this one, this icon. Okay, pasting. Okay, all statements and then a semicolon. Let's see if we can run this thing. There it is. It's everything. Yellow submarine, help, close to you, Angie, satisfaction. So there was no order by, so it's no guarantee that it's going to come out in that order every time you run this query, but 99.9% of the time it does. In fact, I've never seen it once not come out in the order I expected it. All right, so we did that one. Let's do another one. All right, it's just it's going through the steps. Well, we already did all this. Yep. Okay, we ran it. We got the output. Oh, this is different. Okay, where did that come from? Find all songs sung by the Beatles, and each song retrieves the song's name. Okay, you pause the video. You should write this. Write this answer. Even if you have no idea how to do it, write the answer. Give it a shot. If you never try, you're never going to get anywhere with this. Okay, we know we got to select. Type. Start off with select. And what are we trying to get to? Retrieve the song's name. Well, we know how to do that. That is song name. So that part of the mystery is solved. From name of the table is songs. Where, and the only things we want is songs sung by the Beatles. Well, that's going to be artist code. And Beatles is BET. All statements Java and then a semicolon. All right, is that the right answer? I'm going to find out. Okay, let's compare answers. Select song name from songs where artist code equals Beatles. Or Beatle. There it is. Okay, it works. Okay, same answer. So what songs is this thing going to pick? So it's only going to show song names. And the artist code has to be Beatles, so that knocks out Close to You, Angie, and Satisfaction. So only two we're looking at is Yellow Submarine and Help. And I think that's it. Okay, let's see. Do I have colored bars to show all this? No. Wait a minute. That is what we just did. Oh, this is the same one, except we're going to put the names in the song names in alphabetical order. Let's verify that this is exactly the same one. Find all songs. Well, that's what this does. Sung by the Beatles, and that's what this does. And put the song names in alphabetical order. So order by. What is the name of this field? Artist code. That should do it. All statements in Java and then a semicolon. Got a semicolon right here. All right. Shall we compare answers? See if we even got anywhere close to being right. Hopefully we did. Select song name from songs, artist code, Beatles, order by, oops. What does it say? Song name, no, order, put the song names in alphabetical order. I did not read that correctly. It's song name. Did not read that. It is easy. I'm not paying attention. I'm too busy talking to you and trying to get the answer. All right. All right. Got to be more careful. Did it wrong. -1 for me. Okay, now is this the correct answer? Yes, it is. Do I show what's, yeah. What's going to get retrieved is we're only going to retrieve song names. So we're only going to pick these song names, but which songs? The ones where the artist code is the Beatles, the ones sung by the Beatles. Well, that's Yellow Submarine and Help, and that's why we only see Yellow Submarine and Help. We can actually run this in HQSLDB and see what it looks like. All statements end in a semicolon, hit the execute button, and Help and Yellow Submarine, just like it says over here. Okay, So we got that one going. Um, Write the SQL query to find all songs that are on MP3. For each song, retrieve the name, the artist, and the album number. Write that query. Pause video. Write that query. I'm going to write that query now. Okay, we always start with select. What are we selecting? What do we want to see? We want to see song name, artist, and album number. We want to see song name, artist, that's artist code, and album number. And that is album num. Okay. From, well, there's only one table here, songs. Where, and all songs that are in MP3. Well, MP3 is media type, so media type MP3. And has nothing about sorting or alphabetizing, so I think we're done. Which songs is it going to pick? Well, it's going to pick these two, and it's going to show the name, the artist code, and the album number. So it's only going to show these three columns, and it's going to be for Angie and satisfaction. Okay, let's see if we got the right answer. Now, there it is. Let's compare answers. Song name, artist code, album number from songs media type MP3. It works. Okay. And this yellow is highlighting what rows are going to get pulls. What we're going to see on the screen, we're going to see Angie's satisfaction. Okay. All right. Moving on. I think this is the same thing. Find all songs that are in MP3. Retrieve the song name, artist, and album number. Put the names of the songs in alphabetical order. So name of the songs in alphabetical order. So this is going to be order by, and names of the songs in alphabetical order. Well, that's going to be song name. Um, okay, that should do it. All statements and then a semicolon. Let's see if we got the right answer. Um, Song name, artist code, album number, songs, media type, um, order by song name. There it is. Okay. And it's going to pick these two rows. All right. Moving on. Let's do the next one. You do the next one. Write the SQL query to find all songs that are on MP3. For each song, retrieve the song name. Well, I thought we just did this. Isn't this the same as this? Song name, artist code, album number. Put the artist. Okay, it's different. We're putting the artist in alphabetical order. So the artist is artist code. So switch this to artist code. And it with a semicolon. Okay, let's see if we got the right answer. So all that matches. The only thing is artist code, and it does match. And since we're ordering by artist code, well, they're both RS, so it doesn't matter. But we are going to get Angie and satisfaction. All right, enough of that. Oh, what do we do with ties? Because we do have a tie. What do you mean we have a tie? See, we can run this in HSQLDB. Let's do that. You're going to see a tie. All statements in a semicolon, run this thing. It's going to have Angie and satisfaction. Which one comes first? Well, it's a tie. Could be either. Okay. Could be either. It's a tie. There's nothing, there's no documentation that says one is going to be favored over the other. It always says it's unpredictable. Okay, do this one. Did we? This is, I think this is the same thing. Let's check it. We want the artist and the it's then it's MP3, and this is going to change. So this is the album number. Okay, so it only changes that. So let's do that change. Album number. All statements in and a semicolon. All right, let's just verify we got the right answer. So let's order by album number. Let's check what we wrote. Order by album number. Okay, it does the same thing. So which records is this going to pick? It's only going to pick records that of media type of MP3. So these last two, that's the same last two we've been playing with. And it's going to order it by album number. Well, here's the album number. Well, they're both 24, so it doesn't matter. Okay. So we're not going to see any change at all. Try this one. Find all songs that are on track number 1 and that are on CD. For each song, retrieve the song name, artist, and album number. Okay, we already got the song name, artist, and album number from song. So the big difference is the where clause. What are we doing? That are on track number 1. Okay, so we got to do track 1, track num. Track num equals 1. And that are on CD. So and media type CD in quotes because it's a string. All right. That's what I think the answer is. There's no order by. Let's check the answer. Select song name, artist code, album number from songs or track number 1 and media type. Okay, it does do that. So what ones we're going to pick? Well, it's looking for songs that have a track number 1 and that are on CD, and that both have to match. Well, these are the only 3 that are CD, so but that's not a 1, that's not a 1, that's not a 1. We got no match. This is the empty set, empty string. Okay, nothing there. Okay, moving on. Find all songs that are on album 24. We want the name, artist, and track number. Is that what we've been doing? No, this is different. Okay, so we got to pay attention. Okay, this is different. So select. What's getting pulled in? Oh, you should do this. So pause the video and do this on your own and then come back. I'm going to try to figure this out. So I obviously want to select. We want to retrieve the song name. Well, that's easy. Song name. All of this is easy. You just got to think about it. And the artist. So that's going to be artist code. And track number. Okay. From name of the table is songs. Okay, now we're ready to do the where. So what is the where going on? Find all songs that are on album number 24. Okay, so we want to go album number. Where album num. Come on. And I forgot what I was doing. Album number is 24. And with a semicolon. All right, let's see if we got the right answer. We want select name, artist code, track number from songs or album number 24. Did it say anything about sorting? I don't remember. put the track numbers in alphabetical order. Okay, easy enough to do. Order I, and what is the track number? Right here. Okay, got it. Order by track num. Okay, let's check that answer. Order by track num, order by track num. This is a match. Okay, and what is it picking? It's picking album number has to equal 24. So that's these bottoms. That's not 24. That's not 24. That's not 24. These two are 24. So it's picking these two. And so what it's going to return is information about Angie and information about satisfaction. So that's what's going on there. All right. Next. Find all songs on CD. For each song, retrieve the song name, artist, and album number. Okay, that is completely different from what we've been doing. So kill this. Let's start all over. We want to start with a select. What columns are we selecting? Song name. So we know how to do that. Song name. And then what's next? After song name, artist. Well, that's artist code. All right. And then what comes after artist code? Album number. All right. From songs, that's the only table we got, where what? I don't know. Let's see. Let's read it, see what it says. All songs that are on CD. So that's going to be media type. And that is going to be on CD. And put the song names in alphabetical order. So order by, what are we doing in alphabetical song names? Song name. All right. Let's see if we got the right answer. Checking. We've got song name. We got artist code, album number from songs, media type CD, order by song name. This is correct. So which ones is this going to pick up? We want media type on CD. Well, let's find all the CDs. These are the top three. So it's going to pick stuff from the top three. All right. Moving on. Song name, artist. Put the artist in alphabetical order. Is this the same one? Song name. No, artist. No, this is different. This is different. Let's start all over. And this is different. Okay, so we want to pick which fields we're going to see. We are going to see song name. Let's look up how you spell it. Song name. And then what? Song name and the song's artist. So that's going to be artist code. All right, from songs, where what? Find all songs that I have on CD. Well, that's media type. Equals CD. And put artists in alphabetical order. Order by artist code. Semicolon. All right. Let's see if we get that. Do we get the same answer? We're going to find out. Song name, artist code, songs, media type CD, order by artist code. There, we got it. Okay, so what fields is it going to pick? Well, media type is CD, these three rows. Okay. All right. Hopefully that all made sense. We are on the dean's objectives. And so this is going to be, so there are 2 exams for the final exam. This is going to be the first one. Develop solutions to programming problems. Um, so I'm going to give you a programming problem, and then you're going to write Java code to fulfill it. Come up with a solution. Um, it's going to be easy. You've going to be have gone over it many times, hopefully many times, and so it'll be a cakewalk. It'll be easy. Don't worry about this one. Um, Using proper syntax. Syntax is the grammar of the language. So there's tons of grammar in what we're doing right now. I can mess this up easily. I can move select over to here, and that'll mess it up. I can move this line over to here, and that's going to mess everything up. Okay. Um, these are all the syntax rules. It has to be laid out the way I laid it out. Okay. You can't just willy-nilly put things wherever you want. It's not going to work because you're violating all of the grammar rules. In English, messed up grammar will be store milk by go I. All the words are there, but they're so mixed up. The sentence doesn't make any sense at all because we broke all the grammar rules, right? Semantics is it compiles. So you'll know you have a syntax error when it doesn't compile. It throws error messages. Once it compiles, then you can run the code and see if you get the right answer. So if you're trying to write code that adds 2 plus 2 and you're seeing a result of 5,695, well, then you know you got something wrong with the code. That's what a semantic error is. You don't get the correct answer. An example in English would be red ate a mountain. Red's just a color. Colors can't eat anything. Yes, I know there are some people named Red, but I didn't think of that when I wrote this slide a million years ago. Sorry. Um, so a red is a color. Colors cannot eat an entire mountain. That's impossible. The programming cycle did not list every step in the programming cycle, only listed steps that a software developer would be involved in. The first step is gather the requirements. This is easy if you're a freelancer. You sit down with the customer, you ask the customer, what do you want this code to do? And the customer is going to say, I want to do this and I want to do that. And if this happens, make it do that. And if this other thing happens, make it do this other thing. Okay. Pretty easy. And then you and your customer will agree on a price. What if you don't work as a freelancer? What if you work in an office? So you're going to be placed on a programming team. And then the team lead is the person responsible for distributing out assignments. What I like to do is just throw everything out there and let people pick. And I try to guide the interns to pick the easier ones. And my top coders know that if they don't pick the hard ones, this project will never get done, or at least it's going to be severely, severely behind schedule. And so they know they're supposed to pick the hard ones, and that's what they do. They like the challenge. They don't want to do something so easy they would fall asleep while keyboard keying it. That would be horrible. They want a challenge. They want to be stimulated. They want their brain engaged. They want to be able to come up with new ways of doing something. That's what they live for. That's what they strive for. Just about all software engineers do that. We strive for new and exciting projects. Once we're on a project for 2 or 3 years, it's time to move on. So we'll try to find another project to hop to. Okay, I don't know why I got off on that tangent, but I did. Other ways you can get requirements is the team lead will call a meeting and we'll just start saying, okay, we need code that does this, who's interested, and we need code to do this other thing, who's interested. Just go all the way down the list, and then you're supposed to volunteer for your task. Now, if you don't pick anything and then you make it all the way down past the list, then whatever's left over is going to get assigned to you, which is bad because there's a reason why people didn't pick those, right? It has to be some reason. And so now you get to play around with it. Oh, lucky you. So you're really encouraged to speak up and pick something. So some team leads, they will publish the list before they call the meeting. Other team leads won't. So big surprise. You have no idea what's coming. Some team leads will assign individual tasks to individual people. So everybody on the team will be assigned a task by the team lead. That's a lot of work because you got to phrase it right, then you have to distribute it, and yada, 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 yada. It's a lot of work. No thanks. I don't want any part of that. Too much work. Okay, but some kind of way you are going to get requirements. So what do you do next? Now you've got to take these requirements and create a design that satisfies all those requirements. So for this class, the design is going to be pretty easy. You're just going to write pseudocode. What the heck is pseudocode? It's code written in plain, ordinary English that describes what the code is going to do. Pretty easy. So what if you're the advanced coder has been hanging around for 20, 25 years? You're the expert. You are the best coder in the whole company. Well, you're going to pick the really hard task. That hard task might require writing 100 pages of code. They are not going to be doing pseudocode. What they're going to do is divide up their tasks into individual classes and objects, create UML-like diagrams for every class, and the top will be the name of the class, the middle will be the properties of all the objects from that class, and the bottom will be all the methods that the objects can do. And then they're going to come up with a completely set of different diagrams to show how objects interact with each other. The best example I can come up with is a baseball pitcher and a catcher. The pitcher throws the ball to the catcher. These two have to cooperate, right? And so how do they interact with each other? Oh, I lost my train of thought. So we did, we were talking about design. Oh, yeah, got it. Okay, well, so that's how we got off track on design. And then they would have to come up with a brand new set of diagrams to show how um, various actors will react to events. Like if somebody moves the joystick, somebody better do something, right? Because there's a gamer trying to play a game and they're moving their joystick around. Something on the screen better be moving. Like usually it's the main character, but it could be something else. Um, Okay, so that's the design. Once you have the design, then you're going to convert your design into actual code. By when we get to midterm, we're going to switch over to Java and stay on Java till the end of this class. So we'll get a large dose of Java. So it's going to be Java. You're going to write your code in Java, at least for the final exam. Um, Once you've written your code, you're going to test it. What are you testing for? So many people write tests for bugs. No, your primary objective is to get paid, especially if you're the freelance. Remember the agreement you had. If I write code that does all these things, you're going to pay me this amount of money. So they're really motivated to demonstrate to the customer they've met all of those requirements. And how do they do that? They sit down with the customer and says, okay, you asked me to write code that does this, and then you run the code and show them, see, it does that. And then they'll say, you asked me to write code to do this other thing, run the code. See, it does this other thing. And they're going to go down every single requirement and demonstrate that to the freelancer and says, okay, I've met all the requirements, now pay me. Well, what if you're on a programming team? How does that work? That depends on the team lead. What I do is I ask everybody to write computer like tests. Well, then I can run the tests. So they're software tests. I can run the tests, and each test should the test should cover all of the requirements, and just run the test and see if they pass. Not all team leads do that. Some team leads, I've seen this happen many times. They'll act like they're the customer and you're the freelancer, and you're going to go through that whole spiel where you said, okay, this is the requirement. Let me run the code and show you it meets that requirement. Here's the second requirement. Let me run the code and show you that requirement. So I've watched this. It's slow, but it is interesting, especially if you haven't seen it before, because if they do it at a team meeting, all of us are looking together. So and you say, holy moly, I didn't know we had code that did that. That's really cool. Or you can say, oh, that's boring. So you get different reactions depending on, sometimes we know what the other person's working on. Sometimes we don't. So it depends if you're helping the person or if they're asking you for help. So if that happens, then, we have a conversation. And so you get to know a little bit about what they're working on. So it all depends. Okay, so that's testing. The other way to do it is, so if you're in a big corporation, they have departments dedicated to testers. Everybody in that department, the only thing they do all day long is test other people's codes. Well, how do you do that? Well, the software developer will have to create a test plan. It said it's a checklist. So it's going to say something like, um, uh, run this code and click this button and do you see this? And then they check the box yes or no. So if they check yes, they see it, test passes. If they check the no box, means they didn't see it, test fails. And they go through. So this is very tedious. It's very time consuming to write this checklist. But I get it because now you're fully documented that you have met all the requirements because every single requirement is in that checklist. Okay. Is represented by some tests for that checklist. So yeah, it's great for documentation, but somebody has to write all that stuff and then give it to the human tester, and it has to be written well enough so the human tester will understand what what you're asking them to do. You can't be vague; it has to be very specific. So it's very time consuming. I've been on projects like that. Um, Okay, so testing is not for testing for bugs. There's always bugs in the program. It is, did you meet all the requirements so that you can get paid? I guarantee you, if you're in the office and your project misses a deadline, there will be consequences. You don't want to miss deadlines. It's not good for your career. um, and Especially if you're the cause of the team missing the deadline and you're the only cause. If everybody else met all, did all of their work except you, you got an issue. You don't want to be that person. I've never was that person. You know, but anyway, we're getting way off topic. Okay, so we've tested it. We've met all the requirements. We made the sale with the customer. We got our money. Is there any way we can make more money? We can go into maintenance mode. In maintenance mode, we charge the customer for fixing bugs. Now think about this. Let's say that you just bought a brand new car, 0 miles on it, from a car dealer, and you drove it home and it falls apart. What are you gonna do? Well, you're gonna call the car dealer and said, "Your car fell apart. I expect you to come out here, pick up all the pieces, reassemble the car, and give it to me for free because it's under warranty." That's not how software works. We know there are bugs in the code. The customer knows there are bugs in the code. They don't know where the bugs are. We don't know where all the bugs are, but we know there are bugs in the code. We don't fix those bugs for free, and we charge the customer to fix those bugs. So it's really interesting, completely opposite what you're expecting with a warranty. We don't offer a warranty. All we offer to do is we met all the requirements. That's it. That's the only thing we say. We don't offer a warranty, no guarantees. We just said it meets all of the requirements, period. Done. That's it. That's all we're committing to. It's a really strange way to run a business, but that's how it's done in the software world. And so you can make money by fixing bugs. You can make money by offering new features. You're the freelancer. You probably sold it to somebody who owns a company. They took your software and gave it to the people who are going to use it. And people hate change. They're going to criticize everything about it. They're going to try to shoot it down in the hopes that they're not going to force them to use this new piece of software. And so there'll be a long list of complaints, and the owner is going to have to shift through it, from legitimate complaints from just, they're just being very negative, who cares what the color of the background arrow is? Who cares if this box is 1 inch to the left or 1 inch to the right? Nitpicky stuff, but there are some important stuff, like if there's a bug that prevents the person from actually doing their job, that's important. That has to be addressed. And so they'll come to you with these bugs, sheets and mounds of paper, or if it's electronic, long list of bugs. And it's a negotiation. Like, how much money are you willing to spend to fix these bugs? So it's a negotiation. They said, okay, here are all the bugs. How much would it cost to fix all of them? And the price would be way too high. So, how about if we just fix? So you start crossing things out. Don't care about this. Don't care about. How about this shorter list? How much would it cost? And it's a negotiation. You're going to go back and forth until both parties come to an agreement, and then there it is. So for this amount of money, we're going to fix these bugs. Another thing you could do is updates. So especially if you have thousands of customers, you can just update and charge customers for a monthly subscription fee if they want updates as soon as you make them. for free. It's not for free because they got to pay a membership. All right, every month they got to give you a check, but that check is for to cover all upgrades. So really cool deal for the software company, right? Because they're continuously making money on this, so they can offer like security patches and maybe fix a bug, a new feature to make things easier to do, and things like that. And there's lots of people that do that kind of stuff. Anyway, so maintenance is after the fact, after the sale. Can you still make money off of this deal? Well, you can offer put new features in. Um, Pseudocode is code written in plain ordinary English, describes what the code is going to do. A comment is just a comment in the code that describes what the next few lines are going to do. It could be the next line or a couple of lines or 3 lines or whatever, just a small number of lines, so the next few lines are just going to do this. So what I like to do is take my pseudo code and I put it into my code and make them all comments. And under each comment, I actually write the code that implements that one line. And so I have converted my pseudo code into comments. And then under each line, I write the code. Very few people do that, but it makes it a lot easier to write the code because now you're focused on, okay, this part of the code has to do this. And then, no, if you stay with the same company, months or years could go by and somebody is going to say, hey, see your name is on this piece of code over here and you wrote this. We need to make a change to it. Now, if this code like had thousands of lines of code in it, you're not going to remember what it is you did, when you did it, why you did it the way you did. But I will, because I have these comments in my code that describes everything from start to finish, because I took the whole design, all the pseudocode, and put it into the code as comments. So I know all the pieces that I did and why I did it the way I did it and all the steps I followed, because it's all there. Other people don't do that. So they have to relearn why they did it the way they did it before they can fix the problem. Anyway, that's the end of the lecture. All right. I'll see you next time. Bye.